How do you make a boat go faster? Powerboat racing is a multi-million-dollar industry. But why do some teams win the big prizes more than others, when in each race they all have the same size engine, the same conditions to race in, and pretty similar drivers? The answer is actually simple: diagnostic analysis. Every time a boat races, an onboard computer is collecting data on everything that slows it down: air resistance, water drag, weight distribution, acceleration, and so on. After the race, the team used diagnostic analysis to understand the data and find a solution to making the boat go faster. This approach is used in everything from making bikes for the Tour de France to designing the next generation of fighter jets. The diagnostic tools allow us to understand the data and to work towards solutions. Well, in maths, we also use diagnostic tools, and one of the most useful is called the discriminant. We follow different questions and steps from powerboat teams for sure, but the principle is the same. We use a particular process to give us information about the solution. So let's work out how to go faster. This is Think 4. At National 5, the discriminant was applied to roots of a parabola. If b squared minus 4ac is greater than 0, then the curve crosses the x-axis at two distinct places. If b squared minus 4ac is equal to 0, then the curve touches the x-axis at one point. And if b squared minus 4ac is less than 0, then there are no points of intersection. In the higher course, we use the discriminant in wider contexts. The most common question type would be using it to find an unknown when you know the nature of the roots, such as find the value of k, which the equation x squared plus 4x plus k minus 5 equals 0 has equal roots. But the discriminant can be used in other contexts, and it isn't always as clear that you'll need to use it. You can use the discriminant to test to see if a line and a circle intersect. First, substitute the line into the circle equation, and then apply the discriminant to the resulting quadratic. The discriminant is testing to see how many points of intersection there are, if any. And there are three possibilities you need to decide between: 2 points of intersection, 1 point of intersection, or no intersections at all. This question says, the line y equals x plus k is a tangent to the parabola y equals x squared minus 3x. The line is a tangent to the parabola, so there will be 1 point of intersection. Once the equations are combined, there's a quadratic formed. We can use the discriminant to find the unknown because we know it will be equal to 0 for 1 point of intersection. In this question, from the 2019 paper, candidates were asked to factorize the function shown. 2 linear factors can be found, and the remaining factor is a quadratic. Many candidates did this question poorly and spent far too long trying to factorize the quadratic, when all that was needed was to use the discriminant to show that the quadratic had no roots and therefore would not factorize further. Maybe we underuse the discriminant. It's a quick check we can make on a quadratic to see if it has roots, but also if it will factorize at all. It can be used to determine if curves and lines cross and to prove tangency. So as well as being a test, the discriminant is also like a multi-tool that we can use in many different areas of the course, and we must be able to use it well. Just like a racing team, you have to learn to select the right tool for each bit of the job you're doing. Use the wrong tool and you risk not solving the issue. So if you want to do well at higher maths, or if you want to win the big money in the World Powerboat Racing Series, get a firm grip of diagnostic tools. Maybe you want to do both. This was Think 4. Thanks for watching.